I want to look at the next type of factoring, which is kind of one of those special types of factorings. We did difference of squares, but now I want to look at something called perfect square trinomials. What do I mean by that? A perfect square is if you look at something that is an a plus b and we square it, we're going to get something. I want to show you what we get. And the way we did this is I'm going to use the algebra tiles method, but I want to show you how this works. Look at this. If you got a square with lengths a plus b, then the area, which is length times width, is just this a times an a, which is a squared, a times a b, which is an ab, and a times a b again, which is ab, and then b times a b, which is b squared. And you'll notice that this a plus b squared works out to be a squared plus the 2ab's plus b squared. Okay. So how does this work? Well, wait a second. Before I figure out something else, I want to show you what this looks like just in case it's a negative in there, right? Same idea. A minus b all squared, which means this side times this side to give you a squared again. This is now going to be minus ab. This is now going to be minus ab. And this is now going to be a minus times a minus, which is a positive b squared. So this guy squared becomes a squared minus 2ab plus b squared. Now, how is this going to benefit us at all? Let me show you the next question. Boom. Okay. I've written them up here so that you can see what they look like. Okay, and we can refer to them. Now, look at this. There is your a squared. That a squared is 1. So if you were to square root that, a works out to be 1. Look at this. This would be your b squared. Square root it, that's of course 5. Check this out. Look at the formula. Look what the formula says. The formula says you can take your a and your b, which we know is 1 and 5, multiply them together, which is 1 times 5 is 5, and multiply it by 2 and get the middle term. Ta-da! Isn't that cool? So basically what this is saying is, okay, this can be now factored because this is a perfect squared, can now be factored to this. A plus b, 1 plus 5, okay, and square it. But wait a second, where's the x go? Well, the x goes with the first term, of course. That's what this guy factors down to. Okay, so watch what happens when we look at another question very similar to it. Okay, here we go. Check this out. We have to identify the a, which we know is the square root of the first number. So that's 7. We have to find the b, which is the square root of the last number, which we know is 4. One of them has to be an x, of course. With the subtraction here, it follows this pattern here, okay? Boom, squared. That's how fast it is. If you can see the pattern, it works beautifully well. And how do you know that that in fact is 56? Real simple, because this tells you it's got to be minus 2ab's. So 2 times a, which is 7, times b, which is 4. 7 times 4 works out to be 28. 28 times 2 is 56, and there's the negative. Look how incredibly easy this is if you can see the pattern. Now, let's say you can't see the pattern. Let's say you look at this and go, oh my goodness, I don't know what to do here. Well, guess what? Just rely on your old standard. You know this is PSA 2. Let's go PSA 2 this. But you're going to get just really crazy numbers right away, which is hilarious. Watch this. This is a PSA 2. Watch this. You know that this is going to be a 49 times a 16, and that's going to give you, add up to minus 56. And you're probably saying, oh my goodness, what am I going to do here? Well, you know what? Watch this. Break down 49, which is 7 times 7. Break down 16, which you know is 4 times 4. Okay? Look, try 7 and 4, which is 28. That's 28 times 28. How do I know? Because 28 plus 28 adds up to positive 56. So guess what? Both of these have to be negative. All I did was break down the factors of this astronomically huge number and just choose one from this side, one from this side to see which one works. And you'll see that that's minus 28 and minus 28. Now all I have to do is decompose. So there's 49x squared minus 28x minus 28x plus 16. Group factor like I've always done, right? Okay. Group factor like I've always done. I know I can take a 7x out of here, leaving me with 7x minus 4. I know I can take a minus 4 out of here, leaving me with 7x minus 4. And check this out. 7x and minus 4. Look at that. And 7x and minus 4. And that works out to be 7x minus 4. Perfect square. Isn't that pretty? So even though I may not like that perfect squares pattern, I can always rely on what we've always learned, which was PSA.